In this tutorial, I'm going to introduce Apollo Client and show you how you can use it in your applications. Apollo Client provides a sophisticated and extremely powerful GraphQL client for your applications with officially supported integrations for many common libraries. Apollo Client is a part of the Apollo platform, which is created and maintained by the Apollo team. The Apollo platform also includes Apollo Server for creating production-ready GraphQL APIs, as well as Apollo Engine for performance monitoring and schema management. We'll cover both of these in another tutorial. If you are unfamiliar with GraphQL, I will give a short overview here, but I definitely encourage you to explore the official website and documentation. There's also a great documentary on YouTube describing the motivation behind the technology. GraphQL is an open source query language that allows developers to architect APIs for modern applications. We send our request to a single endpoint rather than the ambiguously defined endpoints created in REST architectures. On the server, we can combine and modify data from multiple resources. On the client, we define exactly the data we want and get nothing more, nothing less. This diagram from TopTal provides a great view of the difference between REST and GraphQL requests. In REST architectures, we make multiple different requests to different endpoints that serve predefined data to our application. GraphQL allows us to pass a single request that returns exactly the data we defined. Here we have an example query to retrieve a specified user by ID and the response from the server. As you can see, we get the exact data we specified in our query. Here are just a few of the companies currently using GraphQL in production. GraphQL was originally developed by Facebook and later open sourced. Hopefully you have a decent understanding of the benefits to using GraphQL. Apollo Client provides developers a powerful but easy to use library to handle all of the data management in our applications using GraphQL. Along with data fetching, Apollo Client also makes it very simple to implement advanced features like caching, pagination, optimistic updates, subscriptions, and more. We can also use Apollo Client to manage local application data in the same way that we fetch remote data. This can replace the need to use a third-party state management libraries such as Redux. There are many companies that have adopted using Apollo in production, and just a few of them are listed here. Apollo Client has multiple ways to implement your GraphQL requests, whether your preference is using the new hooks API, render props, or higher order components. Here's an example of a typical REST API call from a React application. There are many shortcomings in this approach, and just some of them are listed here. Here's an example implementation of Apollo using hooks. We start by defining our request as a variable using GQL to parse our query, which we wrap in a template literal. We then define a normal functional component as we would in any other React application. With the new hooks API, we simply destructure the loading, error, and data states from the useQuery hook with the query we defined as the first argument. We can pass additional arguments for our query variables, cache updates, polling intervals, and many other powerful features. We will build a very basic demo application to allow us to focus on using Apollo Client. It will have just two components, one for retrieving our posts from our backend and one to create new posts. I will start from an application made using the Create React App CLI, the four listed packages, and basic styling of our posts and create post components. We'll follow the steps outlined to implement our Apollo client. Let's get started. Let's begin by exploring our current project structure. Our index file is the entry point to our React application. We render a container and header for basic styling, as well as our posts and create post components. Inside of our post component, we're mapping over a temporary array of posts and displaying the post author, as well as the post content. This is wrapped in some basic styling elements from our UI library, and here are a temporary array of posts. Finally, we have our create post component that returns an input that will allow us to create new posts. We have an onChange handler that keeps track of the current value and state. We'll add an onClick handler that will execute our mutation with our hook. Here's our current application. We're rendering our header, our temporary hard-coded list of posts, and an input tag to submit new posts. Let's get started adding Apollo Client. First, we import Apollo Client from the Apollo Boost package, which we'll use to create an instance of our client. We'll pass the URI to a GraphQL server. You can pass additional configuration here for features such as including authorization headers and passing cookies. Our query and mutation hooks will need to make use of our client instance. To do this, we wrap our application in an Apollo provider, which will pass the client we created to our hooks via context. Now that we have our client created, we can start fetching data from our server. First, import GQL from Apollo Boost and use query from the Apollo hooks library. Next, let's define our query as a variable. We will query the ID and content field for all posts, as well as the author's ID and name. Now we can make use of the useQueryHook, passing our query variable as the first parameter. We can destructure the loading, error, and data states from the hook. We can now remove the temporary post array and return the data we received from the server. Let's return a paragraph telling the user the query is loading and an error message if something goes wrong with our query. If the data returns successfully, we can map over the returned post and still return the author's name and post content. Adding queries is this simple with Apollo, and we don't have to worry about handling any of the information manually. As we can see, we are no longer getting the hard-coded posts we previously defined. It looks like the query and hooks we created are working. Now we can add a mutation allowing users to create new posts. Just like with queries, we start by importing GQL, but now we will import the useMutationHook rather than the useQueryHook. Let's define a createPost mutation with arguments for passing the post content and author ID. The useMutationHook returns a tuple with the function to execute our mutation first, and we can destructure the loading, error, and data states second. We'll pass our mutation as the first argument and our author ID and content variables as the second argument to our hook function. We'll pull the post content from our component state and simply pass a hard-coded author ID. If we successfully create a post, we want to reset the input, and we can do that by passing an onCompleted handler. To run our mutation, we need to provide the function we defined in our tuple to the onClick handler for our submit button. We can use the loading state from our hook to disable our input and show a loading indicator when the mutation is in progress. Let's check and see if our mutation is working. If we type in some input and submit, it doesn't appear to be working, but let's try refreshing the page. Now our new post is showing, and you're probably wondering what happened. This is because the original post query is cached locally, and our mutation is not automatically forcing the query to be rerun. Let's return to our codebase and fix this issue. We will solve this issue by passing an update function, which will add a result to the cache. The update function receives our cache as the first argument, and a data property containing our mutation result as the second. We first need to read the current data in our all-post query. Let's export this from our post component and import it here. We can then manually override the cached array of posts with our mutation result added. An alternative would be using the refetch option, with the downside being another request being made to the server. Let's see if this resolved our issue. We can create and submit another post. Awesome, this is a much better experience for our end users. We have now learned how easy it is to set up and use Apollo Client in our applications. For more advanced features, feel free to continue exploring the documentation.